Hi guys, today I'm going to be discussing and teaching you all about rational numbers. In this lesson, you will learn about rational numbers, which includes terminating and repeating decimals. Rational numbers are simply numbers that can be written as a fraction or a ratio. Previous knowledge that you will need includes the basic operations such as subtracting, division, addition, and multiplication. You will also need to know how to convert a fraction into a decimal using a long division. Here is an example. So you can easily convert the fraction 3/4 into the decimal 0.75, but it can be different when you do long division. So to do long division, you divide the numerator, which is the top number, by the denominator, which is the bottom number. So in other words, the denominator goes outside the bracket while the numerator goes inside. You must place a 0 with a decimal point after the numerator because you're working with a number less than 0. When you do long division, you can pretend that the decimal points don't exist and act like you're just dividing 4 into 30 for now. First, divide 4 into 3.0, which you can think of as 30. The closest you can get is 4 times 7, or 28, which will give you a remainder of 2. So write a 7 after the 0, above the division bracket, and 28 below the 3.0 under the division bracket. Under that, write 2, your remainder, or what you have left when you subtract 28 from 30. Next, add another 0 to the 3.0 so you have 3.00, or what you can think of as 300 under the division bracket. This will allow you to drop down another 0 to the right of the 2 so you can divide 4 into 20. Divide into 20 to get 5. Write the 5 to the right of the 0.7 above the division bracket. Don't forget to add your decimal places back. Your final answer will be 0.75. Core lesson. You will use long division to write fractions as decimals and use the remainder to distinguish between a terminating and repeating decimal. Here is a repeating decimal example. For the first example, we start with the numerator being divided by the denominator. We should set it up like a regular fraction to decimal, long division conversion. First, we write 9 into 4, which is 0. From then on, we add zeros behind the numerator until we get a result. These zeros can be known as trailing zeros. However, 9 goes into 40 completely 4 times every time. This gives us 36 every time we multiply. Subtracting 36 from 40 always gives us 4 again. Tacking on the trailing zeros gives us 40, and the cycle starts over again. Because of this, we find out that this is a repeating of 0.44444, and so on. We can present this large repeating decimal by placing a bar over the pattern number, which making it 0.4 with a bar over the 4. The bar represents it's a repeating decimal and goes on forever. Now for the terminating decimal. You begin by setting it up the same way. The numerator 27 goes inside and the denominator 24 goes outside. Now 24 can go into 27 one time, so put a 1 on top and a decimal point behind it. Now it is time to use your trailing zeros behind the 27. Put a decimal point behind the 27 and follow with 3 zeros. Divide the other numbers into 27. The numbers given should be 1, 2, and 5 behind the decimal place of our first 1. Because it's a terminating decimal, it has no remainder and doesn't repeat on like the repeating decimal. Your final terminating decimal conversion of 27 over 24 should equal 1.125, and this is a non-repeating, of course. Common mistakes many students make when working with terminating and repeating decimals and just rational numbers in general is that they fail to recognize whether a decimal repeats, or they can also not realize the correct sequence in which a decimal repeats. With terminating decimals, it's also a mistake that the decimal place is written incorrectly and the negative side is forgotten or misplaced. Here's an example. By the result, the decimal is 6.2155151. This is a repeating decimal. By the example, the 6.2 is not repeating, but the 15151 is. A common mistake with this would be putting the bar over the 215, like 6.215 with a bar over the 2115. However, if you did this correctly, the answer would be 6.215 with a bar over the 15, which continues into 15151. In this lesson, you have learned to convert a rational number to a decimal using long division, now knowing that the decimal form of a rational number terminates in zeros or eventually repeats. Thanks for watching, and I hope you have a better understanding of Chapter 4, Lesson 1, Rational Numbers.